Hello, mathletes. Today we're going to talk about transformations, section 2.7 from the book. So here we have some definitions. You can pause it if you want, but we'll kind of go through these as we go. All right, so first we want to talk about parent functions. And so parent functions are kind of the most basic functions of their type. And so this first one is a constant function. So we've seen constant functions before. These are horizontal lines. Okay. And with all these, we're going to just kind of graph them and see why they are what they are, right? Just to kind of see why they have the shape that they have. Okay. So a constant function takes this format like we've seen before. We've seen it y equals b. We've talked about in class, but we're going to use f of x equals c in this case, where c is a constant. All right, so c is the constant. And for the purpose of this exercise, we're going to use f of x equals 5 as our constant. But remember, c could be anything, right? C could be 3, it could be 2, it could be 1.5, it could be 0, it could be negative 4/3, etc. All right, so when we have a constant, basically if my function here is f of x equals 5, and if I start inputting these values, like let's say I input -8, well, in a constant function, there's no other variable. There's no place to put the input. There's no x, right? And so I'm just going to get 5. Oops. All right. If I plug in -6, I'm just going to get 5, right? If I plug in -4, I'm just going to get 5, right? And so forth and so on. No matter what you plug in as your input, your output is going to be 5, right? And so if I plot those points, first one, -8, 5 is right here, -6, 5, -4, 5, -2, 5, 0, 5. There's the y-intercept. 2, 5, 4, 5, 6, 5, 8, 5, and 10, 5. So if I graph this line, we can see it's a horizontal line, right? That goes through 5 on the y-axis. All right, so that's what a constant function looks like. And we're going to talk about transforming these functions later too, but it's important to know what the basic function looks like, so then you can, when you transform it, you kind of know how it should start and where it should go from there. All right, the next one is a linear function. The book calls this identity function. So let me write that down here. And you'll kind of see why in a minute. So identity function, but it's basically the parent function of the linear function, right? We know y equals mx plus b is a normal linear function. It's kind of the general linear function. So what we're saying is hey, let m be 1, so we have that 1x there, and we're saying let b be 0, so we have a plus 0 there, right? Anything plus 0 is itself. So it's basically 1x plus 0. So we could graph this without plotting all these points, right? Because we know that the y-intercept would be 0 and the slope would be 1. So we can go up 1 over 1, and we can draw a line through that, right? So anyway, that's what this is. It's a linear function, but it's called the identity function. The reason why is because if f of x equals x, that means if I put in -8, that means I'm going to put -8 in here for x, right? And so what I'll get out is -8. If I put in -6, what I'll get out is -6. If I put in -4, what I'll get out is -4, right? So we can see no matter what we put in, that's what we're going to get out, right? Let's just make sure it works with the positives. F of 2, I'm just going to put in 2. F of 0, I'm going to get 0, and so forth, right? So no matter what you put in, that's also what you get out. So if I plot these points, -8, -8, -6, -6, -4, -4, -2, -2, 0, 0, 2, 2, 4, 4, 6, 6, 8, 8, 10, 10, right? So we're just gonna connect the dots here. All right, so that's our parent. That's the parent function of a linear function, also known as the identity function. And that's what it looks like.